Hi, Assalamualaikum. We are from Group A4AS1204_9. In this video presentation, we will explain about the chromatography, specifically in application of chromatography in forensic science.
This is our group members. The first one is Dina, Nur Shazwina, Nur Nafisa, and Fatih Nur Shamimi.
Hi, my name is Nur Shazwina, and I will explain about chromatography. Chromatography is a technique in which the components of a mixture are separated based on the difference in the rates at which they are carried through a fixed or stationary phase by a gaseous or liquid mobile phase. The first one is planar chromatography, and the example of planar chromatography are paper chromatography and thin layer chromatography, or we call it TLC. The other method is column chromatography, and the examples of it are gaseous chromatography and supercritical fluid chromatography. In this video presentation, we would like to introduce one of the technique in chromatography, which is thin layer chromatography, or TLC. TLC is a method used to separate the components of a mixture. This separation happens on a thin layer of adsorbent material, which is coated onto a solid surface, usually a glass plate. There are two key components in this process. The first one, the stationary phase, and the mobile phase. The stationary phase is the solid layer, usually made of adsorbent materials like alumina or silica gel. It remains fixed on the plate and helps trap or slow down different components based on their interactions. The mobile phase is a liquid solvent that moves across the surface of the plate. It carries the mixture components with it. Each component travels at a different speed depending on how strongly it interacts with the stationary phase. In this video, we will explain one of the uses of TLC, which is to compare the red pigments in different lipstick brands. This helps us to identify and separate the different dye components present in each sample.
Next is a theory. In forensic science, scientists often use thin layer chromatography to study evidence from crime scene, especially when it involves colored or chemical substance like dyes, ink, or powders. A small amount of the sample is placed on a TLC plate and the test is run to separate the different components in the substance. Each component moves a certain distance on this plate depending on its chemical properties, creating spot. To compare samples more easily, scientists calculate using this formula. RF value is equal to distance traveled by the compound divided by distance traveled by the solvent front. If the RF value and spot patterns from the crime scene match those from a suspect, it can help show a connection. TLC gives forensic teams a reliable scientific way to link evidence to people, making it a valuable tool in solving crimes. Next, I will explain about how scientists use thin layer chromatography, which is TLC, to study the pigment found in lipstick. As we know, lipstick is made of many ingredients such as dye, wax, oils, and color pigment. These ingredients have different chemical properties. TLC is a special method that can separate the components of a mixture based on how they behave in a solvent. It works by using a TLC plate coated with silica gel, which is a polar substance. If the compound is a polar, it will interact more strongly with the silica gel, so it will move slower up the plate. If the compound is non-polar, it does not stick as much and will move faster with the solvent. As the compound travels, they form spots on the plate. Each spot appears at a different height and tells us how far that compound has moved. We measure this movement using RF value. Each pigment has its own unique RF value, so we can use the pattern of spot to identify or compare lipstick sample. This technique is very useful in forensic science, especially when investigators find a lipstick stain at a crime scene. They can use TLC to match the stain with lipstick sample from suspect. TLC is not only effective but also a quick, low-cost, and non-destructive way to screen evidence in the early stage of investigation.
Hi, my name is Nur Nafisa, and I will explain about the methodology. This is an example experiment about comparison of red pigment on different lipsticks that use TLC chromatography. Number 1. A piece of cotton cloth was washed in a detergent solution. Immersed in hot water and dried. Number 2. This cloth was cut into small pieces and lipstick streamers were rubbed onto these pieces. Number 3. The stain area from the closed piece were cut and transferred into serial marked small bulbs. Number 4. These samples were mixed with an extracting solution and each bulb was then shaken for 5 to 10 minutes to remove the stain from the closed piece. Number 5. Closed piece is taken out and the extract was used for further examination with TLC. Number 6. Obtain gel with lid, piece of filter paper and a TLC plate. Handle TLC plate by the edge only. Number 7. With a pencil and ruler, draw a line across the short side of the TLC plate about 1.5 cm from the bottom of the plate. At even intervals label the top of the plate with the letters 1B to 6B for 6 different well-known brands of red lipsticks on a single TLC plate. Similarly, 1L to 6L for 6 different local brands of red lipsticks. Number 8. Using a capillary, place a dot of each lipstick sample along the bottom of line directly under the labels on the top of the plate. The dot should be about 0.2 cm in diameter and dark to visible. Number 9. Using a pipette, dispense mobile solvent into the jar. The mobile solvent should be about 0.5 cm deep. Number 10. Carefully insert the TLC plate into the jar. The lipstick dust must be above the mobile solvent. Secure the lid. Number 11. Allow the mobile solvent to rise to within 1 cm of the top of the plate 5 to 10 minutes. Do not allow the mobile face to rise to the top of the plate. Remove the TLC plate and mark the solvent front with a pencil. Number 12. Measure the distance the mobile solvent move in cm. Also measure the distance in cm each component of the lipsticks move from the spot pencil line. Number 13. Determine the RF for each lipstick's component of all lipstick sample. To calculate the RF value, divide the distance traveled by each lipstick component by the distance traveled by the solvent. Here is the result. The RF values were calculated using distance solid travel divided distance solvent travel, DSU divided by DSV. All of these values are shown in the table. The RF values of the red dyes of the local brands of lipsticks are found in the table 1 and in the well-known brands are found in the table 2. Table 1 displays the result derived from the local brands of lipsticks, in which a sample marked as 1L shows 6 pigments having concentrations of red dye present in the different well-known and local brands of lipsticks. There is no characteristics data which could differentiate among the lipstick sources, and therefore the concentrations of the red dye were not a unique identifier for the lipstick sources. The concentration of red pigments varies among these well-known and local brands within just a small constant sample of red lipsticks. The chromatogram of local lipsticks on table 3 shows the majority of the local brands that contain more than 2 dyes pigments in table 4 above, while the branded lipsticks only contain 1 or 2 dyes pigments in table 5. There was no significant differences in the HRF values, and the local and branded lipsticks had a big enough range to be able to use as a unique feature.
Conclusion: this experiment demonstrates that thin layer chromatography (TLC) is an effective technique for comparing red pigments in different lipstick brands. The method also highlights the role of RF value in forensic investigation, as they can be used to match pigment samples found at crime scene. Analysis revealed that local lipstick brands typically contain more than 2 dye pigments, while brand products usually contain only 1 or 2. This suggests potential difference in formulation between local and international products.